All right, today we're going to continue our introduction to geometry by talking about triangles. Now the triangle is the shape we're going to talk about the most this year, or basically this semester. The first semester we're going to do a lot of geometry, and we're going to see some different shapes, but the one we're going to talk about the most is a triangle. Now every triangle has three sides. I think we all knew that. That's kind of the definition of a triangle. And each side is a line segment, which is one of our vocab words from last week. Now a triangle also has three angles. That's actually where the name comes from. Tri means three, so triangle means three angles. And then it has three, and I'm going to use a new word here, it has three what are called the vertices. And when I say vertices, that's plural or more than one vertex. So vertex is a word that we use for angles. If you have more than one of them, you don't say vertexes, you say vertices. But basically it's the 3 points that we use to make the triangle. So here's a triangle, just a basic triangle. I labeled the vertices, A, B, and C. That's the 3 points that I use to make that triangle. Now, if I wanted to name that triangle, I would start with the triangle symbol, just draw a little triangle, and then basically I can put those 3 letters in any order I want. So there are 6 possible correct names for this triangle. The most obvious one is triangle ABC. We usually put them in alphabetical order. But any of the other 5 work also. You could call it triangle ACB, triangle BAC, BCA, CAB, or CDA. So typically we go ABC, but any of those 6 are technically right. Okay, so for our next section, I'm going to go over 6 vocabulary words that you guys probably already know from before. They come in 2 groups of 3, and once you see them, I think you'll go, yeah, I remember these. The first set of 3 is about the side lengths. So if you have a triangle where all 3 sides are exactly the same, we call that an equilateral triangle. If you have a triangle where 2 of the sides are the same, but the third one is different, that's called an isosceles triangle. And if you have a triangle where none of the sides are the same, each side is different from each other, we call that a scalene triangle. So I left myself a little bit of space. I'm going to draw a picture of each one. An equilateral triangle might look like this. And what you would probably do, the way they mark sides equal, like in a geometry book, is they put little marks like this on them. Those 3 little extra marks that I drew are showing you that those 3 sides are all the same. Now in an isosceles triangle, maybe I have 2 sides that are the same, but the third one is, in this case, shorter. It could have been longer, but it's different. So what I would probably do for this is put those marks in to show that those 2 sides are the same, but not put a mark on the third one, so you know that the third one is different from those 2. And then a scalene triangle is like triangle ABC from the last slide. You draw pretty much anything you want as long as no 2 sides are the same. And you have 3 completely different sides there. That's what those 3 words mean. All right, our next group of 3 vocab words also go together, and they have to do with the angles. All right, a right triangle is any triangle that has a right angle in it. And a right angle is 90 degrees. It's one of those perfect square angles, like the corner of a square or a rectangle. An obtuse triangle has one angle that's bigger than that. Just one, and any angle that's bigger than 90 degrees, bigger than a square angle. And an acute triangle is one that doesn't. All 3 angles are less than 90. They're all smaller than a right angle. So I'm going to go ahead and draw you a picture of each one again. Here's an example of a right triangle, and in fact, I'll start with a right angle. So let's say I draw that perfect square angle, and that little square symbol I used is usually there for a right angle. That's a right angle. Now, if I just connect the ends of it, that's what we call a right triangle. Now, an obtuse triangle has one that's bigger than 90. So maybe it has one angle that looks like this, something bigger than that. And then you connect it and you make a triangle. It wasn't very good straight lines, but you guys get the idea. One angle bigger than 90. And then an acute triangle could be something like, remember our equilateral triangle from last one? None of those angles are bigger than a right angle. So that's what we call an acute triangle. All right. Now, when you're talking about angles in a triangle, remember when we did angles last section, I said we always want to use 3 letters to name an angle. We want to call an angle A, B, C, or P, Q, R. If you're talking about just a triangle, this is one of the times it's okay to use 1 letter. And the reason is that there's only one you can be talking about. And I'll show you exactly what I mean in the next example. For the next example, I'm going to show you one of the things we're going to do a lot this year. We're going to take the new things we're learning and we're going to mix in things we already know how to do, like solving equations, one of the things from Mod 0 from earlier. So, I said I gave you guys 2 triangles. We have triangle ABC on the left, and we have triangle PQR on the right. And I said in the triangles above, angle B is equal to angle Q. And this is what I was saying on the last slide. It's okay to just use 1 letter here. If I say in this first picture, angle B, the only angle I could be talking about is this one right here, the one where B is the vertex. And over here, if I say angle Q, the only one I could be talking about is this one right here, where Q is the vertex. So angle B is the one I colored in green. Angle Q is the one I colored in purple. They're both the ones I put a number in. So if I told you that those 2 angles are equal, then the 2 numbers must also be equal. The number for the first one was 3x minus 10, and that must be equal to the number I gave you for the second one, which is 80. If I say solve for x, it's not even a triangle question anymore. We turned it into an equation. So we're going to solve the equation. Now remember, from equation solving, we can do anything we want to the equation as long as we do the same thing to both sides. If I want to cancel out a minus 10, I do that using a plus 10, but I have to do it over here also. So those are gone. I get 3x equals 80 plus 10 is 90. And then I want to cancel the 3. And I do that by dividing. So if I want to cancel out that 3, I'm going to divide both sides by 3. That 3 cancels with that one. And the answer to the question is 90 divided by 3, which is 30. So we took our new thing, our triangles, and we mixed in a solving for x question. But that's our main thing for today. We want to learn our new notation for triangles. We reviewed some vocabulary, and we might want to tie in some equation solving.